So thank you very, very much for having me here. This title is a bit of a joke, obviously, and I was hoping it would resonate with any Douglas Adams fans in the audience. Are there any? No? Okay, I've been a fan since I was 18. And the sort of lesson is that, you know, we have to critique, but we have to also hold things a little lightly in order to survive. With the permission of the chair, I will spend a couple of minutes acknowledging ICTS's contribution to our cause, because this is a conference on gender equity. When the Working Group for Gender Equity under the Indian Physics Association was launched, I proposed that Women's Day 2016. It took a year to get launched, 2017. 2018, ICTS supported a discussion meeting, a public discussion meeting, and also alongside the first in-person meeting of our working group, which was called Pressing for Progress 2018. And for the first time, sexual harassment in the workplace in physics was openly discussed. It's all on YouTube. That was amazing. And then the following year, we had the Pressing for Progress Hyderabad 2019 conference, where, as I mentioned yesterday, 3 men faculty from ICTS participated. They were not invited. They came to learn, apart from postdocs and students, and apart from financial support. And of course, Rajesh Gopakumar was an invited speaker in the panel. And the logo of our working group was actually designed by ICTS, by a graphics designer called Joni Wilfred, who worked here at the time. And I did want to acknowledge that early support for our cause. So I was born a year after Sputnik was launched, and so it was a very different ethos, I think, from what it is now. Science was very thick in the air. It was always on the news in English, in Kannada, and Yuri Gagarin and Valentina Tereshkova were my childhood heroes. I had the privilege of growing up in a home full of books. And so at age 8, I read this book for children called The Atom, which had Rutherford's gold foil experiment, which completely blew me away and also opened my eyes to how the scientific method worked. And there were many things. I got into the world of this Adivasi child in Bastar called Chandru, who learned, it seemed, about nature just by living. I, of course, read Marie Curie's biography and a lot of Soviet science books, which were available very cheap at the time. Many from my generation will speak to this, and they were available both in English and in Kannada. There was science, there were little booklets on little science things, there were science fiction stories, children's stories. This had a major influence on me, which is a space age tale about space travel, but also about very open, healthy relationships between men and women. And at the end of all of this, I wanted to become a scientist on a spaceship, a dream that I dropped in high school. But I particularly wanted to mention these books on mathematics that I read in high school. And I think they were a major influence to having me not see mathematics as something difficult. And I hope I can speak to this towards the end of the talk when I present statistics and all that. But I think that is something really, really important, that we as scientists do not project our discipline as something difficult. So my parents had this habit of putting a mat on the garden, and we would watch the night sky after dinner, and it was fantastic to try and discern planets from stars, from artificial satellites, meteors. A beautiful comet showed up, which huge angular size, and I painted it with the mango tree in the foreground. This is not my painting. There's a painting of somebody who did it from Australia, who landed up becoming my collaborator later on in life, which is cool. And even though I grew up in a town, we could, this was half a century ago, see the Milky Way. Little did we know, however, at the time, that at the center of the Milky Way is a supermassive black hole. And I can never tire of showing this result, which is my most favorite astrophysics result, which all of you know won the Nobel Prize in 2020. And now, we of course know that every galaxy that has been looked at has a supermassive black hole in its center. And not only that, the extremely compact supermassive black holes scale with both the stellar velocity dispersion of the galaxy and the mass of the bulge of the galaxy. And this cannot be due to gravitational coupling. So the central black hole and the bulge have to grow hand in hand. And so one way in which they can grow can grow and give feedback in order to comply with these scaling relationships is by accretion. So there are two ways in which supermassive black holes can grow. One is by merger of galaxies, which result in the merger of supermassive black holes, and the other is accretion. And we know that every accreting supermassive black hole produces bipolar synchrotron-emitting jets. And a small minority, Preeti has talked about this yesterday, produce extremely high kinetic power relativistic jets, which scale up to even megaparsec. And there is good evidence to believe that the majority galaxies which produce these jets, those jets are not relativistic, they're sub-relativistic. For example, we have this result where we looked at the ratio of the radio emission from the nucleus to the total radio emission measured simultaneously and found no difference, systematic difference between face-on accretion systems and edge-on accretion systems. You would expect such a difference if the jets were relativistic, and because they would be Doppler boosted. And also, there are many evocative examples of how these outflows from the accreting systems impact the circumnuclear environment, both on the interstellar medium scale, which is what is shown on the left, and on the much larger intergalactic scale, which is shown here. So here you have the radio structure superimposed on the X-ray emission, and you can very clearly see how they punch through the hot intergalactic medium. And of course, it is also a result that the scaling relationships are complied by with accreting supermassive black holes as well. So we know that this must happen because of some sort of regulation of star formation in the circumnuclear environment by the accreting system, but the exact mechanisms are still not understood. Of course, mergers of galaxies and therefore their supermassive black holes and accretion of the supermassive black holes are not disjunct processes. So this is one example from our own work, a wet merger remnant, which is one of an interacting trio. And we observed it with an optical IFU, with radiant interferometry, and with the Chandra X-ray Observatory. And with the IFU, we confirm the two accreting supermassive black holes. So this is an image from the IFU where the H-alpha emission is channeled into the red color, N2 emission into green, and O3 into blue. And then we can apply the Baldwin-Phillips Tetravich diagnostic to determine whether the ionization is due to star formation or due to an accreting supermassive black hole. And in this case, both the supermassive black holes in this merger remnant turn out to be in the accreting supermassive black hole ionization mechanism regime. And in the radio, we detect both the components with a radio spectrum that is consistent with being synchrotron emission. And in X-rays also, we detect the two accreting supermassive black holes. And so it is an illustration of how when two galaxies merge, their supermassive black holes merge, but they also trigger to accrete, and they produce what are likely baby synchrotron emitting jets. So one of the things we asked with this multi-frequency kind of investigation is there a relationship between the galaxy axis and the accreting supermassive black hole accretion axis? So you probably know that previous studies have shown that there is no relationship between the overall host galaxy axis, if there is one, and the accreting supermassive black hole axis. But I'll show some examples where the inner star-forming ring does seem to have a relationship, at least in some cases. So this is a galaxy called NGC 613. This is the optical image. This is our IFU image, again with the same scheme, namely the H-alpha channeled into red, N2 into green, and O3 into blue. And you can see evidence for extended oxygen-3 emission. This and this are the same image, this just zoomed out. And also evidence for a star-forming ring, which is the H-alpha N2 emission. And at radio frequencies, these are the radio contours of the overall galaxy, which is unsurprising. And the inner structure inside this little square shows evidence for both a synchrotron emitting jet and a star formation ring. So this is another example, very similar. Galaxy IFU image, extended oxygen-3 emission. Sorry, I can't get stable. Extended oxygen. How do I make this? Okay, extended oxygen-3 emission in this direction, star-forming ring, and the inner radio jet, parallel, of course, to the oxygen-3 emission, but perpendicular to the star-forming ring. And this is the third example. Again, very similar. Here, the star-forming ring is quite extended and edge-on. This is a much nearer galaxy, so much better spatial resolution. And the oxygen-3 shows the iconic biconical structure, and the inner radio jet is again parallel to that and perpendicular to the inner star-forming ring. So I want to go back to Andrea Gherz's result of having discovered this supermassive black hole in the center of the Milky Way. And she said, I grew up hearing the word no all the time. You're a girl, you can't do it. You're a girl, you can't get into Caltech, MIT, etc. Now, if I had heard this while I was growing up, I would have been very surprised, because I described to you the kind of ethos that was prevalent when I was growing up. I went to a very ordinary grant-in-aid school, Kannada medium, first 7 years, and later switched to English medium. And I had teachers, all women, who were, my only men teachers in school were for music, dance, and Kannada. And all my teachers, they came from lower middle class families, dependent on teaching for their livelihood, but they were extremely diligent, enthusiastic, and acknowledging. And I had never heard them, any of them, say to anyone about how science was not meant for girls, either to me or to anyone else. And it was a very similar experience in college. I encountered this kind of a thing, ironically, when I entered the elite institution of the Indian Institute of Technology for an MSc, and later on in TIFR, of course. So I always remember this comment that a sociologist called Geeta Sen made at one of the first meetings, I would say the first meeting, to discuss the gender equity question, which happened in IIA in 2008 as preparatory to She's an Astronomer. This is Geeta Sen. She's a different person from Geeta Chadda, who was here yesterday. She's a sort of much senior sociologist from here, and we got her to chair that discussion. And she said she's an astronomer. I don't know if you remember, but She's an Astronomer was the cornerstone project of the International Year of Astronomy. So that was the sort of context for us to have that meeting. And she said it's all about intonation. So she said there was a time when we would say, she's an astronomer? Seriously? No, that's not possible. And we are now, meaning in 2008, and I think still, in a situation where we say, oh, wow, she's an astronomer, how amazing. And we want to be in a situation where we can just say, she's an astronomer. That was Geeta Sen's insight, which has really kind of stayed with me. So some data which some of you have seen before, some of it is published. This is the fraction of physics PhDs employed in higher education in India who are women. So 19% skewed already. And when you come to the Indian Institute of Technologies, that fraction drops a bit. And then to the even more institutes of claimed excellence, namely TIFR, IISc, it drops even further. And full disclosure, I'm an alum of all these three categories. You can make what you will of that. So if you look at prestige on another dimension, so for example, governing councils, Academy Fellows, the Raman Memorial Lectures, this is as of 2015. Again, the fraction drops drastically. And so in the Hyderabad Charter for Gender Equity in Physics, which came out of the Pressing for Progress conference, and also earlier in the Pasadena Charter and now in the Waterloo Charter, one of the sort of guiding principles is that when the process of selection reduces the gender fraction from that in the pool, it is a signature of a biased process. Exactly the same trend of decreasing fraction of women with so-called excellence or eliteness is reflected in caste as well. This is a paper published in Nature by Ankur Paliwal in 2023. I have reordered his institutions. I don't think anybody will argue with me that JNU thinks it's better than BHU, and these people think they're better than JNU, and so on and so forth, and TIFR thinks they're the best. And you can see how the fraction, the caste fraction goes down. And so this is the problem we have. And we certainly don't want this, which is a so-called equality intervention. We don't want this either, which is really fixing the women. That was out of the core goal when we launched the Gender in Physics Working Group, to have institutions and individuals and whoever else step away from trying to fix the women and get into fixing the problem based on the evidence. So we really need to fix the bent tree. Another thing I want to dismantle is this idea that there is a lack of interest in science among girls, and a lot of public funding is being spent on this, but there is no evidence for it, and I think it's barking up the wrong tree. So women's enrollment in undergraduate science is 40%. The Inspire Fellows, as of 2015, have been won by at least 50% girls. In physics, 50%, in all sciences, more than that. The Indian Academy of Sciences Summer Fellowships also have been won by more girls, even in 2015. That's 10 years ago, right? So there's no evidence that that's what is needed, but a lot of effort, energy, and public funds are spent organizing special science camp for girls, special summer school for girls. Like I said, I think that's barking up the wrong tree. So some things are easy to fix. So the C.V. Raman Memorial Lectures fraction was 3%, and the moment our working group was launched, it rocketed, because it was the Indian Physics Association that determined it. And so it was just a matter of us sitting at the table and supplying a list of women who have done good physics research and give good talks, which is, I mean, pretty trivial if you ask me. So I don't know why it didn't happen until then, but it required us to intervene and do this. And now I think this fraction has not dropped. I've not done a recent study. It is important to look not just at the numbers, but also at the quality of the outcome. So this is the Indian Association of General Relativity and Gravitation meeting of 2022. I think there are some people here. I think, Aru, you were at that meeting. So they had good numbers, which was great, but the point is a bit beyond that. this is my Facebook post on that meeting when it happened. I wasn't at the meeting, but there were enormous number of comments which said it was one of the best meetings that they had attended. And this is a comment by Ajit Parameshwaran from here, who, I mean, he's like, I would consider him a stalwart in the field. He said, I must also add that all the plenary talks were excellent. The conference was also full of young people. This was certainly the best IAGRG meeting I have attended and one of the best conferences I've attended. So it's when the intervention happens in the right way, then the quality of the outcome is also fantastic. So it's not just about the numbers. Fixing the system, so both this trend and this trend reflect the same thing, that as we go up in claimed excellence, which is claimed to be based on merit, the problem becomes worse. So this is a question many of us have been asking. This is a question I asked at the last IUPAP, well, not the last, but the 2024 IUPAP General Assembly. Are we as physicists really constructing merit in a way that actually promotes understanding of the universe in the best way? So this is what I would like you to pay attention to. This is again a result 10 years old. On the y-axis is the gender gap among PhD students in a given discipline. On the x-axis, these two scientists surveyed practitioners of various disciplines and asked them how important is brilliance to success in your discipline. And you can see physics is one of the biggest offenders. This panel is for the natural sciences. This is for the social sciences, all in the United States. And so greater the emphasis on brilliance as perceived by the practitioners, larger is the gender gap. So that, I mean, this has been in place for a while. These people have gone on to do more, dive deep and do more research on all of this. But there is very little acknowledgement of that within our discipline. But there are some counter examples. So this is a project called Astro 3D, which was a national project in Australia, awarded in 2017, multi-million-dollar, multi-node, etc. Lisa Cooley was the PI. And when she got the grant, she was already determined that she would achieve gender parity within her project. They were not hiring faculty. They were all hiring postdocs and graduate students. So she, right off the bat, put in place processes in order to achieve her goal. So this is from a paper she published in Nature in 2023 at the end of the project. And so here are the advertised, this is the fraction for the respondents to the advertised positions. So the pool, basically. And it has 30% women. And this is the selected distribution, so 50% women. They achieve parity. There was a small fraction of positions in the project that were not advertised, and the PIs, the nodal PIs, were allowed to hire their own postdocs. And there, of course, the fraction of women is extremely low. And she has talked about in detail how they put mechanisms in place to achieve this, which included gender sensitization of the committees and retention policies, having mechanisms to increase feeling of belonging, and all of these. So these were not for women. These were for everybody who were hired in the project. And this is another, again, my favorite counter example. So as you know, the Hubble proposals call happens every year. In about 2014, I think, the associate director did a study and found that only while 23% of men proposers succeeded, only 19% of women proposers succeeded. This is over many, many years. So they got worried. If this had been in India, they would have done a fix the women thing, and they would have said, let's have a proposal writing workshop for women, because women don't know how to write good proposals, okay? That's not what Space Telescope did. So they tried to tweak their proposal format and so on. They got 50% women panelists in all the panels. That didn't change anything. Then they brought a team of sociologists led by this person to first 1 year to scrutinize their processes, the next year to actually sit in the panels and be participant observers and watch the discussions. And they recommended double anonymized review. So once the sociologists recommended double anonymized review, Space Telescope, led by Louis Tolga, had to work very hard with the community to get buy-in, because the proposers have to make sure they write their proposals without actually revealing their identity. It's not enough to just have a double anonymized review at the end. And they got that buy-in. They did all that hard work for a year. And that year, the fraction flipped. And that year, 2018, Priyambada Natarajan was the chair of the whole process. And this is what she said. For me, the experience was eye-opening. It really steered us back to what a review process is supposed to be. Not a review of the PI, but a review of the science. It was a complete reshaping of the discourse, which was fantastic. So, and I mean, several of us have been on NASA panels in these kind of reviews, and we know how it's so easy for I mean, I think maybe you have been in a generation post this, so it's different. But when in my time, I have certainly experiences where time was given not on the basis of the science of the proposal, but on the basis of the person. So I want to end with this quote from Lila Watson, one of the representatives of one of the indigenous peoples of Australia, who says, if you have come to help me, you are wasting your time. But if you have come because your liberation is bound up with mine, then let us work together. So equality is everyone's work, and we need to fix the system and not the women. And I think that is the way forward. So thank you.
Thank you. Questions? We can do one or two.
Yeah, my question is on the science part first. I was curious that, I was not aware of the result that, there's no correlation. I'm not aware of the result that there is no correlation between the accretion axis and the galaxy axis. So, but it's curious then that the star formation ring is somehow correlated. So what is the main idea behind that? But also, I was just thinking that, in the NGC 613 case, the jets seem to be, the axis of the jets seem to be perpendicular to the galaxy axis, or is that not true?
No, it's, see, this is sort of a little bit inclined, right? So it's like that. And so the galaxy axis is sort of like that. And the star forming, so the dynamics, it goes on, right? Secular evolution goes on for millions of years. And so there are star forming rings which are formed in the process. Bars form, star forming rings form. The bars are not necessarily permanent. So I guess it's not, so it was an expectation that the host galaxy axis and the accretion system axis would be aligned. And that was not found to be the case, which, if you think about how the evolution across cosmic time happens with a lot of not just mergers and interaction, but also flybys which affect the gravitational orbits and so on. And think about the scales, the scales are very, very different. This is host galaxies of, 100 parsec, and the sphere of influence of the black hole is extremely, extremely small. So I would say even the star formation ring is outside the sphere of influence of the supermassive black hole. But the accretion is fueled by stuff going towards the center. And so when stuff goes towards the center, on the way, it possibly forms these star-forming rings, etc. And so then, it's not, I guess that's surprising that the smaller structures, these are much, much smaller structures close to the center, are actually aligned. I'm not saying this is the case in every galaxy we've seen. I just showed a few cherry-picked examples. This is not a statistical result. So, yeah.
Thanks.
Yeah, ma'am, about the Hubble's proposal.
Prajval,
Sorry.
please.
Okay, Prajval. The Hubble's proposal, can you just please bring that slide? The second last slide. Yeah, the results about the 2018, where the gender was not disclosed. What happened after 2018? Are they still following this?
So
or?
after that, they put it in place for all telescopes, Hubble, James Webb, the works.
So presently,
So I have the data. I have not put it on a slide. I have the histogram. I can show it to you later.
So that histogram is now, I mean, not.
It remains, yeah.
Okay.
I mean, this difference is small.
Yeah,
so I don't know if it always
that's
but
okay. But the proposal nowadays is not according to what it used to
yes,
be.
yes.
So that has been taken care of.
Yeah. Yeah.
I have a question on the science.
Oh, sorry.
Yeah.
Whoever. Is that okay?
Yeah.
Okay.
Okay. So for SMBHs, when you make the statement,
I think you should please. I have some hearing loss. So,
okay.
yeah.
Can you hear me now?
Yeah.
For SMBHs, when we make the statement that every galaxy has an SMBH at the center, how strong is that statement?
Every galaxy we've looked at, I don't know about the galaxies we haven't looked at, but every galaxy we've looked at has evidence for a supermassive black hole. The evidence, of course, we sort of nowadays go on a ladder in the sense that dynamical evidence is only measurable for very nearby supermassive black holes. After that, there is this ladder, right? So we look at the broad emission lines clouds, so-called, which we believe are Keplerian and driven by the supermassive black hole. And so the width of the emission lines we use as a measure of the mass of the black hole, and so on and so forth, as we go further and further towards the beginning of the universe. So we don't have dynamical evidence for those faraway galaxies, for a supermassive black hole in the center of the universe.
So,
but yeah.
My question was, because early in 2025, I saw this paper written which uses hypervelocity stars as a probe to say whether there is a supermassive black hole at the center of LMC. At the end, the paper also.
Oh, LMC, okay.
Yeah, and that was surprising to me because LMC is a nearby galaxy, and we are questioning the fact, is there a SMPH at the center? And then at the end, it does measures the mass as well of the LMC through the process of Hill's mechanism. So that's my first question.
Very low mass galaxies, there is a debate about whether it has a supermass, and it's also a question of definition. So sort of conventional definition for no very sacred reason is that supermassive black holes are 10 to the power 6 solar masses and above. And these kinds of galaxies, if they have a very massive dark object in their center, and if they comply with this scaling relationship, then that mass would be a bit lower. And this whole annoying problem about intermediate mass black holes is really annoying. We don't have enough of them, and we don't know why, and all of those things. And then measuring this velocity dispersion that could be driven by a black hole that is intermediate mass in the center of such a system is very hard, because you need extremely high spectral resolution in order to determine, because the stellar velocity dispersion comes out to be very small. So I don't know this paper. It would be a very interesting paper, but they're probably singling out some stars to look at the. Yeah.
So one more question. So related to this, I was thinking about whether SMBHs at the center of a galaxy could be related to the Emery formation, extreme mass ratio in spiral objects. Is there? I tried to find literature. I couldn't because I don't
Sorry,
know.
what extreme mass ratio of what?
In spiral. So
In spiral.
yeah, extreme as in so when two objects in spiral, if the mass difference between them is very different, then it's called extreme mass ratio because
That's for coalescing black holes. You mean. Okay.
yeah. So could SMBHs or the presence of SMBHs drive the formation channel of Emery's extreme mass ratio?
So can SMBHs drive coalescence of extremely different
I think
mass black hole
sorry to
pairs?
interrupt.
Is that your question?
Yeah. I think we'll
I
leave the
don't know.
longer discussion.
You have to ask. There's a dynamicist sitting right here. You can ask her.
Yes, definitely a nice topic for the discussions. Bhashati, want to make a quick comment?
Just regarding this IAGRG 2022, I was actually pleasantly surprised because they invited me to be on the SOC, and they said that there are not too many senior, so I was already the chair of DAA, so that's why and I thought it was a very good initiative on their behalf, and that probably reflected in the outcome of the program they came up with.
That's right. Yeah, and it was, Sumati Surya was the president at that time, and the credit also goes to the previous president, who was Patrick Dasgupta, because the processes started then. I requested Pallavi to send a Google form around to everybody, and I would be really interested to see your responses to that. Thank you.
Yeah, thank you, Prajval.